Hello, Science 10, and welcome to our review on molar mass. We're going to just do a quick reminder of how to calculate moles using molar mass, which is the addition of all the masses of a compound from the periodic table together, and then the mass given in an equation. So in today's lesson, you are learning how to review the mass formula, molar mass formula. You're going to learn what the molar mass of water is and the importance of that. You're going to learn how to possibly rearrange the formula if needed and explain why we need molar mass in physics. How are we using it? So, in chemistry, we use moles to show how much of a substance we need. So, if you think back to our chemistry unit, we learned about molar mass being if I had a compound like copper 2 sulfate, I would find the mass of copper, the mass of sulfur, the mass of oxygen, and then I would add them all together. That is molar mass, okay? And what we're doing is we're trying to find moles. Now, moles is a working number that we use that helps us understand how much we need within a chemical reaction, because we know that what goes into one side of the chemical reaction has to come out. But in physics, what happens is we talk about something called specific heat capacity. Now, it's not just in physics, it's across the board in science, but we're going to talk about it in our physics unit specifically. A lot of times we are not given moles. In a question, you are, but in a real life situation, such as in the lab, you're going to be given the mass of something. So given the mass is the more or less common way that you'll see now questions from now on with molar mass equations. Because the mass is something we can actually physically weigh in the lab. So you need to be able to figure out how to solve for moles when we give you a mass in your specific heat capacity equation, which we haven't learned yet, but we will. So the formula for finding moles of a substance is as follows. N equals little m over big M. So the line between the little m and the big M means division. So N is for moles. Little m is for mass in grams, and molar mass is weighed in grams per mole. So unlike chemistry, where again, we had to add up all of these different compounds to get molar mass, I'm giving you the molar mass for all of our calculations that we're going to do in our physics unit. And it's going to be 18.02. And that's because in specific heat capacity, we are going to be using only water. So that means we are going to use that number no matter what. So 18.02 grams per mole. So let's look through the first two examples, example 3 and example 4. So let's start with example 3. An ice cube has a mass of 1.23 grams. How many moles are in this cube of ice? So we have to start by setting up our question. We're going to write down our variables. So we're solving for n. It says how many moles. So n we don't know. Our mass is 1.23 grams. Our molar mass is 18.02 grams per mole because ice cubes are essentially made of water. They're frozen water. So I already told you that the molar mass we're going to use for water is always 18.02. All right. So I'm going to have both of those in an equation. So let's write the equation down and solve. N equals little m, or mass divided by molar mass. I'm just going to take my 1.23 grams and my 18.02 grams per mole, and I'm going to divide them to get 0.0683. Okay. Now, again, I am acknowledging significant digits. Because of division, I have 3 significant digits here. Because in division and multiplication, we use all the digits. So because I have 3 digits here, my answer of 0.0683 has 3 digits, because the 2 zeros out front don't matter. The 683 is what matters. So I have 3 significant digits, and there is my answer. So in example 4, it says how many moles are in 165.3 grams of steam. So again, I'm going to set up my questions by writing down my variables. What is my moles? What is my mass? And what is my molar mass? Again, molar mass is 18.02. I know this because steam is just boiled water. So again, water. So now what we're going to do is we're going to write our formula down. Moles equals mass over molar mass. We're going to plug our numbers into our formula. And again, I'm going to honor significant digits. Both of these have 4 significant digits, so I am going to use 4 significant digits. So my answer is 9.173 moles. All right, so those are the first 2 examples in your notes. Example number 5, I won't be discussing with you until after we've talked about specific heat capacity. So we're going to review this one more time after we've learned how to solve for specific heat capacity. So thank you. And if you have any questions, please let me know. Hopefully you are reminded of what molar mass is and how to solve for moles. And we will be doing some practice questions